Welcome to this session on time, distance, speed. So basically, time, distance, speed, as we understand, has a very correlated relationship. So distance is equal to speed into time, or as we call speed is equal to distance upon time, or as we say, time is equal to distance upon speed, right? So these are the basic tenets we understand, and these would be good enough to solve most of the questions. And usually we follow two approaches when we solve questions on time, distance, speed, or speed, distance, time, as we call it. Either we solve the equations or we put in the values. So there are two ways. You can always solve a question, one and two. Both work well. It depends on each question, and mostly, what suits you as an understanding helps and using the mm, options, whether to solve by an equation or by values. So let's start and understand with one question. A car travels from a place X to Y. So there's a place X and there's a place Y, and from X to Y they travel at a speed of say V, and from Y to X at a speed of 2V, and then from X to Y again at a speed of 3V, and then from Y to X at a speed of 4V. Good. Now then, the average speed of the car for the entire journey. So what is the average speed of the car for entire journey? Somebody who doesn't have much knowledge on time, distance, speed would say, okay, this will be V plus 2V plus 3V plus 4V by 4. That's simple. So this has to be 7. So it's 2.5V. But that would be a wrong answer. Why? Because it is dependent on this formula, and that is speed is equal to distance upon time. And rather, I would say when you want to calculate the average speed, you don't calculate it in this manner. This is totally wrong. We will calculate time of each of this and then try solving it. So there are two ways. First is the matter of what I call as values. So if I am smart and I don't want to waste time, I'll quickly take up a value. Say suppose I know it's gonna be, speed's gonna be V, 2V, 3V, and 4V. So I'll take a number which is, easily handleable. So something like I'll take 100, and let me take a speed which is say 10 here. So the distance is 100, speed is 10. So what would be the first time? 10 speed, it will take how many hours? 10 hours. Then 2V would be 20 speed. And how much hours it will take to cover 100 kilometers? 5 hours. Then 3V speed would be what? It would be 30. And how much time it will take? It will take about 3.3 hours. And then with the 40, how much time it will take? It will take 2.5 hours. So when you add up these hours, you have traveled 400 kilometers and you've spent 15 and 17.5 and then another 18, so it's 21, 20.8. That's the time is, you have taken. That's the hours. So this is time and this is speed, and you've traveled around 20.8 hours. Sorry, time has been spent on 400 kilometers. So what does it come out to be? It comes out to be, we'll divide this and we comes out to be somewhere below lower than 20. Because 20.8, 20 is the square of this, so less than 20. So it's something between V and 2V. So this could be the answer B. This is how we solve with values. Now let us solve this question with not values but equation. So what would it be? So we know distance is equal to what? Speed into time. So the speed is V, time is t1, distance is same d. So next time what happens, because the distance remains same and the speed changes, so t1 would be like, let's keep it as t1. T2 comes out to be what? D upon v2 or 2v, whereas t1 was d upon v, and t3 comes out to be d upon 3v, and t4 comes out to be d upon 4v, right? Total distance we've covered is 4d. That's the total distance, and the total time taken is t upon v plus d upon 2v plus d upon 3v plus d upon 4v, right? We take d out, so what we get 4d, d upon v out, and we get 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. And we take an LCM, we get 12 here, we get 12 plus 6 plus 4 plus 3. So what we are getting actually 4d upon d upon v into 25 by 12, right? Let's put this equation right. So we get 4d into 12 upon 25, and we get t here and multiplied by v. So this gets subtracted, we get 48 by 25 v as the total, the average speed. So the speed we are coming up, v is basically this, so it is actually 48 by 25. So 48 by 25 would be what? Less than 2v, right? So 48 by 25 is less than 2v. So here also we are coming to the same point, it is between v and 2v. Here also we came. So this was a longer drawn process. This is the shorter process because we used values. So basically choosing right values helps you solve questions faster. Let's try solving another question. A man takes half time in rowing a certain distance downstream than upstream. So a person is rowing and he takes, suppose let's assume the speed as s, normal speed is s. Now what is happening, let's the current be at x. What is the ratio of the speed in still water and current? So we know a man takes half time in rowing a certain distance. Distance is fixed, so we know distance is fixed, time taken is half. So let's suppose distance is fixed, and when he's going upstream he will be going s minus x. So time taken is half, so I'll put it as 2t here. When he's going downstream it is d upon s plus x, and he's taking only t, right? So if I put that relationship together, what I get, d is equal to, from this equation I get d is equal to 2t into s minus x, and from here I get d is equal to t into s plus x, right? So basically I'm saying 2t into s minus x is equal to t into s plus x. T gets cancelled off, what I get is 2 into s minus x is equal to s plus x. So 2s minus 2x is equal to s plus x, and I put this there and I get s is equal to 3x. So speed of this upon this is 3:1. So speed of this is 3:1. This is the way we solve with an equation. I can confirm. Sometimes you can solve with the equation and confirm with a value. So let's take a number like 6, because 3 and then 2, right? So if I add, suppose still water, it is traveling at 6 kilometers per hour, current is at 2. When it is going upstream against the current, it will be 6 minus 2 is equal to 4. But when it's going downstream, right, then it will be 6 plus 2, that's 8. So yes, it is the double of that. Time will be halved. When the speed is doubled, it will be halved. If I double the 2s, the time taken will be 1 by 2 of t, right? So by that scenario, I know this has the right answer. So from equation I've calculated, from values I have checked. So this is another way of solving the question on speed, distance, time. Let's try another question. It says a frog tries to come out of a dried well of 4.5 meters with slippery walls. Every time the frog jumps 30 centimeters, slides down 15 centimeters. What is the number of jumps required for frog to come out of the well? Now, this is an old question we have seen from childhood, and I don't think this is much tricky. So this is the height we have to take as 4.5 or 450 centimeter to be precise. Every time he jumps 30 centimeter, he slips 15. So effectively he's just jumping 15 centimeter. But this is up to the point when he jumps last, when he doesn't have to slip back because he's crossed it. So basically 15 centimeter I have to get, and that comes around in 28 jumps. I'll get around 420 centimeter. And what is left is the last 30 centimeter which I have to jump, and that will be in the 29th jump. How did I come to that? I know 15 is there, 450 is enough. 30 would have been an ideal scenario every time, but I know the last jump he would never come back because he has crossed the bell. So that is why this is the answer. Now let's look at another question of speed distance time. So it says this is basically not a speed distance time question, more of a direction question. So I'll put it in the direction. So it says a bank employee drives 10 kilometer towards south from her house. So always when you see south and all, make this, compass kind of a thing where you have this north, south, east, and west. So let's begin. It says a bank employee drives 10 kilometers south. So I know this is 10 from her house and then turns to her left. Now this is the direction, so she turns to her left and then travels another, adds another 20 kilometers. So 20. Again, now see, this is the direction. She turns left again and travels 40 kilometers. So she's traveled 40 kilometers now from where she was. So 40, right? Now this is the direction. Now she turns right and travels 5 kilometers. 5, good enough. Again, she turns right and now travels 30 kilometers. She's come down 30, right? To reach her bank where she works. What is the shortest distance between her bank and the house? Now see, if we see from this axis, which is this, 10 is here, 40 she went, 30 she came back. So actually these are on the same line. So what I need to calculate is basically this distance only, and this is 20 plus 5, and that's 25 kilometers. That is how we solve questions. This helps you put the right directions, and then left right is important through arrows. So when you know which arrow you're working, which direction, then left right is, this is the left, this is the right, it becomes easier. So when I know the arrow, it's the left and the right. So let's solve another question on speed distance sign. It says a person X from a place A and another person Y from place B set out at the same time to walk towards each other. The places are separated by a distance of 15 kilometers. So this is the 15-kilometer distance between X and Y, right? Now it says the places are separated by 15 kilometers and X walks with a uniform speed. So they walks with a uniform speed of 1.5 kilometer per hour. Whereas Y walks at a speed of 1 kilometer to begin with, and then he travels 1.25 and then kilometer per hour and then 1.5 and so on. What is the correct? So let's see, when they're moving in the opposite directions, they'll meet eventually, we know. So in the first kilometer, they'll be covering 1.5 plus 1. So X travels 1.5, Y travels 1. So total comes out to be 2.5 kilometers. In the second hour, he'll again travel 1.5, he will travel 1.25, and he travels 2.75. Then the third hour, 1.5, then 1.5, and becomes 3. So I know subsequently it will be 3.25 and then 3.5. What does it add out to be? So this adds out to be what? To begin with is around 5.25 and then 8.25 and then 11.5 and 15. So actually after 15 kilometers, 5 hours, he is covering 15 kilometers, right? So they take 5 hours to meet. True. They meet midway. Let's check out. Because every time he's traveling 1.5 and he's traveled for 5 hours, 5 into 1.5 is equal to 7.5. So yes, they meet in the midway. That is also the correct statement. So basically we are just trying to visualize and put it on the paper, and we are able to solve these questions. Now let us look at another question which says car A takes 1 hour more than car B that travels at a speed of 60 kilometers per hour to cover the same distance, fixed distance. If car A had double its speed, it could cover the distance in 1 hour less than the car B traveling at a speed. So let's again we always there are two ways to solve a question equation and values. So if I take a value, so I know the mm, B is traveling at a pace of 60 kilometers per hour, right? And A takes 1 more hour, and when it doubles the speed, it takes one less. So I know this has to be a multiple of some common multiple has to come between A speed and B speed. So what could be the possible? So let's start with say suppose 120. That's the next possible multiple of 60. So 120, let's take it because numbers are looking like they're whole integers. So 120, if he is traveling 120, he will take B will take what? 2 hours, and A should take 3 hours at current pace because 1 hour extra. So then A must be traveling at 40. But if A is for traveling at 40 and he doubles his pace to 80, he reaches covers at 120 kilometers in 1.5 hours. So no, that is not the right answer. I know that. Now I move to another option, and that another option comes out to be 180. Let's put it at 180. And 180, 3 hours for B. For A, it would take what? Because 1 hour extra, so 4. So it will become 180 in 4 hours is equal to 45 kilometer per hour. And if it doubles its speed, travels at 90 kilometer per hour, and that will be 2 hours. So yes, that works out well for us. So that could be the answer, and that can be the answer of original speed of A being 45 kilometer per hour and the distance being 180 kilometers. He is able to meet the conditions. So this is how you solve with values. Okay, you guesswork, you second guess the question and you solve it. And otherwise you can solve with the equation. So how can we solve with the equation? Let's understand that now. Now car A takes 1 hour more than car B, which travels the speed of 60 kilometer per hour. So time is being taken by, suppose B is T1 and the distance is traveling is D upon 60, right? So it says T1 plus 1 is equal to D upon the speed of A, right? And it says T1 minus 1 is equal to D upon 2A. So I add those two equations and what do I get? 2T1 is equal to D upon A plus D upon 2A. So I get D upon A out, I get 1 plus 1 by 2 is equal to 2T1 is equal to this. T1 I know is equal to D upon 60. D upon 60 is equal to what? 3 by 2 into D, and D gets cancelled, and 3 by 2 A actually. So A comes here, I get 3 into 2 into 60. I end up getting A as it was 2T1, so I put 2 also here. So I get 3 by 4 and I get A is equal to 45, right? So this is how I get with the equation as well. This is how I solve with the equation. So basically what I did, I start T1 is equal to D upon 60, T1 plus 1 is equal to D upon A, T1 minus 1 is equal to D upon 2A. I added the two equation, we got 2T1 is equal to D this, which adds up to be 3 by 2, 2D into D by 60. I've substituted this value for T1 and I've got this, and then A is equal to 3 by 4 and into 60. That was the value because this goes here and A comes here and this value comes down. So I get 3 by 4, A is equal to 45. So I was able to solve this question from this way, right? I could have solved by this way as well. So there are both ways we can solve questions. So mostly time distance based question, just remember distance is equal to speed into time and we will be able to address the questions. So this is how we solve the question on speed distance.